Hi guys. Today we will finish our material for midterm. Right. So let's review what goes on for the last chapter. So chapter 3, what we have to study is that about the function. So what you have to understand about the function is you have to be able to find the domain, find the range, and also graph the function. So many function that you have to study. For example, the simple one is polynomial. The polynomial function of degree n take the form of an x to the n plus an minus 1 x to the power of n minus 1. And we continue adding up with the coefficient a sub I x to the power of some power until a1x1 plus a0. And if we have an is not 0, so we call the polynomial in this form has the degree n or the order n. Okay, so in this case, if we have here an is non-zero, so we say this polynomial has degree n, degree or order n. All right. So the polynomial is the continuous function. And the domain is a real number. Okay. So it can be any value for the x in this case. The second function that we should know is about rational function. So rational function is is a ratio between two polynomial function. We call the function Pnx divided by Qmx. P is the polynomial of degree n, and Q is also polynomial of degree m. Okay, so that's a degree n, Q is degree m. So n may be equal to m, or sometimes it's not equal. All right, so this is a rational function. And domain, this function has some special things about the domain. The domain can be any real number except that it can be the real number except, so we subtract off with the value of x such that qmx equal to 0. Okay, we not allow the denominator to be 0. So for any x that make the denominator here 0, it cannot be part of the domain. Okay. Another thing is about the some x to the power of rational number. For example, we have a rational function like square root of x, something like this, or we have the n root of x, or it may be something else, not the root of x. It might be y equal to the n root of something. I call the square. All right. And the domain of this is depend on the n. So if n is some odd number, so the domain can be any real number. But if n is the even number, the domain takes only for x that is non-negative. And the next function that we should consider is related to the exponential function. So we have 3, 4 here is an exponential function. So exponential function has a domain. The domain of that is x is a real number, and there are special pattern in the graph of e to the x. So e to the x is going to be something like this. This is function e to the power of x. And if you have e to the negative x, we might have something like this. Okay, so this is y equal to e to the negative x. And we know that at this point, when x is 0, it's always y take 1, right? At this point is x is 0, y is 1. Right. And the last one that we should consider is logarithm function. So this is the inverse of the exponential function. Some properties where maybe we can take a look at the graph of the logarithm. So that's the x, then the y. So we have the basic, the logarithm like this. So this is y equal to the natural log of x. And at this point, when x is 1, the y is take the 0 value. So this is a basic graph that we should know. And next thing is maybe combination between the one of this. Maybe you can have the piecewise function. So piecewise function. So we're gonna separate the domain into pieces. And for each piece, the y value take in different forms. For example, maybe we have a y equal to f1x and f2x, f3x, for example. So this may be when we have x is less than some 0, maybe, and maybe here y gonna take f2 if x is between maybe 0, take it equal until maybe 10, and y take f3 if x greater than or equal to 10. This is for example. So you can change any domain here. So this is, for example, we take 3 pieces, like we have something like 0 here, 10, and for each one of them, okay, for this part, this means when x is less than 0, and here is x between 0 and 10, and here is x greater than 10. Okay, for each of this x, the y value would be f1, and here this piece would be f of 2, and this piece f3. And when we draw the graph, you can consider for each pieces and draw one function only take within the domain. For the second pieces, you take another forms, and so on. Maybe we can have many pieces, more than 3, or maybe we can have only 2 pieces. All right, so that are basic information. And another basic that you have to know is some algebra, basic algebra. Okay, so for example, if we have the x to the power of a times x to the power of b. So if you have the same base like this, multiply each other, this is x to the power of a plus b. And that's formula number one. For example, if we have 2 to the 5 times 2 to the I have -3, for example. So here A is 5, B is -3. That is we can take a 2 to the power of 5 plus is going to be plus of -3. So we got 2 to the power of 2. So that's 4, for example. Okay, A, B can be any real number. All right. So if we have the same base, we can combine the power. Okay. So if we have like x to the power of a to the power of b, this is the same as x to the a times b, or we can have x to the power of b and less to the power of a. Okay. For example, here maybe we have x to the power of square root of x to the power of 3. So this is x to the 1/2 and less to the power of 3. So that is x to the power of 3/2, right? And this is the same as we have x to the power of 3 and take the 1/2 outside, same thing. Okay. Okay. How about the power of okay, how about rational function like we have a square root, the n root of x here times okay, let me write this way. For the example, we have the cube root of x times the cube, maybe the cube root of y. This can be written as x to the power of 1/3 times y to the power of 1/3. So we have different bases, but we have the same power. So that is like we have x times y to the power of 1/3. Okay. Therefore, for example, if we have like square root of 10, okay, this might be raised to the power of the cube root of that. So this is like we have let me write this way. Okay, 1,000, the cube root of 1,000. So this is like we have a 10 to the power of 3, right? So that 1,000 to the power of 1/3. So that is a 10 to the 3 times 1/3. That is just 10. If we have like 20, square root of 20, this is like we have square root of 5 times 4, right? So that is square root of 5 times square root of 4, and square root of 4 is 2, right? So that is times 2. Therefore, we have a 2 times square root of 5. So something like this that you have to be familiar with. All right, let's continue what we left off from last time. We had the function exponential. Okay, the exponential, we're gonna use a lot of algebra, like what we just reviewed. So we have sometimes we don't have the e, but we have any constant b to the power of x. So let's distinguish between polynomial and exponential. Okay, so the polynomial, take the x as the base, okay, and to the power of some number, for example 3. This is polynomial. But if we have the exponential function, it's gonna take like some constant, maybe 3 less to the variable x. So these two are different. So make sure that you understand how these two are different. So polynomial take the x as the base, okay? But exponential, the base is just the constant and the power is the variable, okay? So this is b is a constant, so b to the x is some exponential function, okay? All right, so the graph that this one we just review at the beginning. So this is like y equal to e to the x. This is equal to y equal to e to the negative x. And e is about 2.7 something like this. So this is the estimate of value e is the constant, not a variable. Okay. Um, okay, these are the properties that very important that you have to be familiar with and be able to use it. Okay. So the number one is same base. You can combine the power. Okay. This is the same thing. We have a same base. So this is a to the y, right? We can write as a to the negative y. Okay. This one is a to the x times a to the minus y. So we have the same base. We have a to the power x minus y. So that's a x minus y. And this is a to the x raised to the power of y. So we can combine, we can multiply x and y. So this is the same as we have a to the yx, right? Because multiplication can interchange the order. So that is a to the y raised to the power of x. They are the same. Okay. All right. And the third one is if same base, okay, a to the x equal to a to the y, it means that the power must be the same. And here if x is non-zero, okay, and a to the x equal to b to the x, it means that the base has to be the same. Right? Okay, so next example, we want to show that we want to solve for x. Okay, there are some x here. Okay, for example, the first one, we have 5 to the power of 2x times 5 to the 7 over 5 to the power of 3. This is the left-hand side. Okay, let me simplify the left-hand side first. This is equal to 5 to the 2x. It's same base, right? 5 and 5, so 2x plus 7. How about the bottom? Denominator can be written as 5 to the power of minus 3. Then same base again. So that is the same as 5 to the 2x plus 7 minus 3. So that is equal to 5 to the power of 2x plus 4, right? That's the left-hand side. How about right-hand side? So right-hand side is 5 to the 4x, right? And here left must be equal to right. So that these two must be the same. So we have 5 to the 2x plus 4 must be the same as 5 to the power of 4x. And previously we have the same base, right? This is same base. So if these two are the same, it means that the power must be the same. Therefore, what we need is that 2x plus 4 must be equal to 4x. Okay, that is the power must be the same. Now, we want to solve for x. We can just gather x into one side. Maybe we have we subtract both sides by 2x and minus 4. So we have on the left is 0. On the right, we have 4x minus 2x and minus 4. So we're gonna get 2x minus 4. And in order to solve that, I recommend you to factor the common term out. In this case, we have 2 as the common number, 2x minus 2, right? And this must be equal to 0. So two terms multiply each other and we got 0. It means that one of them must be 0 or both of them. In this case, we see that 2 is non-zero. Therefore, this term must be 0. Okay. So 2 is never be 0. Therefore, this one must be 0. So that means that x minus 2 must be 0. It implies that x is equal to 2. So the question, the answer for this question is x equal to 2. Now, similar to the second question. Okay, second question, let me do this. Number 2, on the left-hand side, we got 5 cubed. And on the right-hand side, we got x plus 2 raised to the power of 3. So the power is the same, right? So same power is mean if these two are the same, equal, it means that base on the left must be equal to base on the right. It means that 5 must be equal to x plus 2 because of this is the same, right? So must be 5 equal to x plus 2. Now we subtract both sides by 5. We got 0 equal to x minus 3. So it means that x is 3. So in this case, x must be 3. How about number 3? Number 3, we got this one is look difficult, right? Number 3, on the left-hand side, I start with the right-hand side first. Right-hand side, we see that we got 2 to the power of 6 times 5 to the power of 6. So the same power, maybe if you want, we can multiply the base. It's going to be 10 to the power of 6. Yeah. There are many ways to solve this problem. Yeah. One way is if we combine this, it's going to be 10 to the power of 6. And we can see that the left-hand side is 10 to the power of x squared. And we can have 10 to the power of x times 2 or 2x. Okay, left and right must be the same, right? Left equal to right. It means that base is the same. In this case, base is the same, right? So the power must be the same. So 6 must be equal to 2x. Therefore, we solve for x. X must be 3 in this case. This is one way to solve number 3. Let me try another way. Okay, this is first, or we can try again number 3, but show you another way. 10 to the power of x squared here. Maybe you can combine this to be 10 to the power of 2x. But if you recognize that the right hand side is there is the multiplication between 2 to the 6 and 5 to the 6. Okay, on the right hand side, it's like we have 2d6 times 5 to the 6. And we notice that 10 can be the multiplication between 2 and 6. So it's 2 times 5 to the power of 2x. So it means that we have 2 to the power of 2x times 5 to the 2x. Therefore, we have the same base. Therefore, 6 must be equal to 2x. Okay, so it's 6 equal to 2x. Again, we got x equal to 3. So in many ways in order to identify the x using this property. All right, let's continue. Logarithm function. The logarithm function. One thing, this is a logarithm base b. Okay, and if you take the power of the natural log. So I give you some formulas again about the natural log. It might be easier if you do this way. So using the property of natural log. So we have properties of the logarithm function. And the first one, we know that the log of E is a constant 2.7, right? So the log of E is 1. So in this one, it's like the natural log and the E is inverse function of each other. Therefore, we can have similar e to the power of log x. This is the same as x. Okay. And we have the another properties like the log of a base b. This is can be written as the natural log of a divided by natural log of b. Okay. This is quite important that I recommend you to use it. All right. Another formulas that should be understand and be able to use it. The natural log, in fact, it can be any log. The log of a times b, this is the same as the natural log of a plus natural log of b. It's like the monitor is not updated. Let's see, is the connection lost? Yeah, it's still sharing. All right, that's number 3. The log of a times b. This is the same as log of a plus log of b. And another one, log of a to the power of c. This is, you can pull out the c as the coefficient times the natural log of a. From these two, it's less to the natural log of a divided by b. This is the same as log of a to the power of b to the minus 1, right? And we can use the property number 3. This is product between a and b to the minus 1. So that is the log of a plus the log of b to the power of minus 1. And we can apply property number 4 to this term. So move the minus 1 here to be as the coefficient of log of b. So that is like log of a minus natural log of b. So this is quite important formulas that we can use for the property of log. And there are many properties, but this 5, I think is very important. And you can apply from this basics properties of natural log. All right, let's continue. Okay, in this note, it said that the common logarithm is here, the log x, log, okay, log x. And no base here is mean base is 10. Okay, it's like no base, but in fact it's base 10. That's the regular number that we use in regular life. Okay, natural log is use notation of ln, but it's log of base e. Okay, like I told you before, then log of any base can be written as log of x divided by log of base e, right? In this case, and log e is 1, so that's just log of x. How about this one? This one is can be log x divided by log of 10. Okay, and the graph of natural log is like this. This is y equal to log of x. And if you use the base b and b is between 0 and 1, the graph is going to be opposite like this. So at this point, it's still 1, 0. This is still 1, 0. Okay, but most of the time we consider this case. We consider the case that b is greater than 1. most of the time. All right. Okay, these properties, I think this is the same as the 5 properties that I told you before. Yeah, for example, let's see, did I forget anything? I forgot another properties. The log of 1, this is 0. And the log of anything and any base is still 0 because of log of 1 is 0. Because of that. So it will imply that I think the other one, no need. Okay, just remember that the log of 1 is 0. Okay, just review all of these 5 properties. And then I will show you using only these 5 to get the properties in the node. All right, let's see. This one, why is it that this one equal to 0? Is because if I write log of 1 divided by log of b, this is the log 1 base b. And because log 1 is 0, and we don't care about the log b, 0 divided by log of b is always 0. And number 2 is log b divided by log b. So we have the same number here. That is exactly 1. And number 3 is like we have the log of b to the x divided by log of b. That is x times log of b divided by log of b, and log of b is cancelled out. It's just the x. Okay, this how we apply the property of log. All right. Okay, how about number 4? Let's see. If we have b to the power of log x base b, this is like b to the log of x divided by log of b. Can I apply this one? Log of b is just a constant. So it might be difficult to use my properties. It's like log of x to the power of, let's see if we have b to the log of b to the minus 1 here. It's quite difficult to do that. But in fact, there is another one. Okay, this might be another one that we should remember then. Otherwise, difficult to show. Okay, number 6. The log b to the log of x base b. Okay, b here is an exponential function, and the log is inverse function. So b less to the power of log b, this is canceled it out. It's gonna get only x. It's like this properties. But it's difficult to apply the exponential. So this is just remember the form just like that. All right. For the number 5, the log of mn base b. So this is like the log of mn divided by the log of b. So this is 1 over log of b times log of m plus log of n. And if we distribute this term to each one of them, we can transform to this one. Right, okay, let me just write this one divided by log of b, this one divided by log of b, and each term is log of m base b. This is log of n base b. Okay, same thing with the 6. And here is just move the power P outside. Okay, and this one is quite important. If the same base, okay, but different m, so m must be equal to n. But in fact, we can use number 8 like log of m base b. This is the natural log of m divided by natural log of b. And this is left hand side, right? And the right hand side is the log of n base b. This is the log of n divided by log of b. And this two is the same. So it means that we can cancel this and that, right? Because they are the same. It means that it's implied that log of m must be equal to log of n. So m must be the same as n. That's number 8. So basically, these are quite basic, except that number 4 that we have to maybe memorize more. All right. This example change the exponential form to equivalent logarithm. So basically, if I start with this, I just take the log both sizes. For example, here I take the log of 4 to the 1/2 on the left hand side, and on the right hand side, I also take the log. We got that, right? And we know that 1/2 here is the power 4, right? We can move as the coefficient. But if you want, you can change that to have the same value because we know that 4 is 2 to the power of 2, right? So this is like log of 2 square, right? That is 4, right? And to the power of 1/2 again, equal to log of 2. Therefore, we can simplify 2 and 1/2 here. We combine or we multiply each other. This is like the log of 2 times 1/2 log of 2. So this cancel. So we have log 2 equal to log 2. Okay, but if you take the form like this, okay, we can just change the 4 to the 1/2 as the using b base, right? If we want x, this one equal to x, it means that we take the base here of the log. It's like this is use property number 4. So we can have 4 to the 1/2. We take the log. It can be like this. But this one, I didn't see what is benefit of rewrite this form. Okay, let's go to okay, evaluation here. This is we can see in the mock exam like this. So if they're given you the log A is 2, log of B is 3, they want you to evaluate. In this case, okay, the log of 10a cubed, we can use properties, right? So that's the log of 10 plus the log of a cubed. And we use the property of log of a cubed here. We move 3 as the coefficient. So we have log of 10 plus 3 times log of a, because they given you log of a already. So this is log of a is 2, right? So we got here is log 10. Maybe we can just leave it at log 10. So that is plus 3 times 2. So we got 6 plus the log of 10. If they given you the log of 10, so we can solve for it. But if they are not given you, just leave it that. Oh, one thing, the log here is log of 10 base 10, right? Log of 10 base 10 is just 1, right? So we got 6 plus 1. So this is log of 10 base 10 that is equal to 1. So we got 7 in this case. And number 2, that's number 1. Number 2, we have the log of square root of a over b. So this is the log of square root of a minus the log of b, right? And they given you log of a and log of b, but a here, square root of a is just a to the 1/2. So we can have 1/2 log of a minus log of b. So 1/2 log of a is 2, log of b is 3. So we got 1 minus 3. So we got -2. How about number 3? Number 3, okay. So because we have a 2 and less to the power of log 2. So this is like, we're gonna get just b, right? Okay, so we're gonna get just log of 2 to the power of log 2, log b base 2. So this is the same as log of b, okay, because of this number here. 2 to the power of log b x is going to return x. So in this case, will be return b. So we got log b. Log b is 3, right? So that's it. Next one. This is also seen in the mock exam. They want you to solve for x. In this case, they given you on the left is log of x plus 1 plus log 3 equal to log of 24. So if we can write in the left hand side just to be log of something equal to log of 24, we can equate the square here equal to 24. Okay, so we use the property of log of a plus log of b. This is log of a times b. So on the left hand side, we're gonna get log of x plus 1 times 3. Okay, this is log of 3 times x plus 1. Okay, the square thing here is going to be this. And this must be the same as 24. So we got 3 times x plus 1 must be 24. Therefore, we solve for it. So divide both sides by 3. So we got x plus 1 equal to 8. So x would be 7. All right. So that's it. In the final, in the midterm, we have we not offer the problem in the trig function. So that's it. That's all the material we need for the midterm. Okay, let me continue with some mock exam. Just guide you through the problem that relate to what we studied so far. All right. Number 1, solve the system using the graphical method. So we just draw the graph, right? And then we try to find intersection. How to draw the graph here? Basically, we can just assume when x is 0, what is y? And when y is 0, what is x? So we're gonna get 2 points and then we can draw the line, right? For example, the first one, x minus 3y equal to 3. If x is 0, what is y? So we have minus 3y equal to 3. So y is minus 1, right? So we got 1.0 and minus 1. And another one, if y is 0, what is x? So we got x equal to 3. So we got 3 and 0. So we got 0 and -1. So this right here. And we got 3 and 0. So right there. So basically the first line would be just like this. let me move afterward. So it's like this. Okay, this is the first line. This is x minus 3y equal to 3. How about another one? When you got 2x plus 3, 2x plus 3y equal to 6. So if x is 0, what is y? So we got 3y equal to 6, so y would be 2. So 1 point is 0, 2. How about when y is 0? Y is 0, we got 2x equal to 6, so x is 3. So we got 3 and 0. So it means we got that 3 and 0, and we got 0 and 2. So let's draw that. We got something like this. Okay, you can easily see that the intersection here. So we have one solution. So solution is what do we call? We have only one unique solution. So solution is x is 3, y is 0, right? So it's what is the wording for that? We have some word like let me what is that? I forgot the wording. System of two variables. So we have something like let's see. Oh, we have independent, right? So this is only one solution. So one solution is consistent and independent. Okay. So solution using elimination by addition. So if I call that equation number 1 and 2, so from equation number 1, why don't we solve for x? X gonna be like 3 plus 3y, right? And here I call that as the A1A. And then I substitute x in the form of 1A into 2. So we're gonna get, so from 2, we're gonna get x is 3 plus 3y, right? This is x from 1A plus 6y equal to 3. And then we solve for y. Now we got 3 plus 9y equal to 3. So we got 9y equal to 0. So y would be 0. If y is 0, then from 1a, you can get the x. X would be 3 plus 3, y is 0, right? So x is 3. So we got answer is 3 and 0. Okay. Now, assume the augmented matrix in this form with the variable x. So it means that it's like we have x and y multiply each coefficient here. Find the constant m and n that make the system has many solutions. Many solution is mean consistent but dependent, right? This is consistent and dependent. All right. To solve this one for infinite many solution. Okay, let's try to do the row operation. How about we multiply so we want to get rid of this term, right, to be 0. This means that we divide the first row by 2. Okay, row 1 divided by 2. So we're gonna get what? We're gonna get divided by 2, we got 2. We got minus 3. We got 6, right? That's row 1 divided by 2. How about we combine row 1 divided by 2 with the row 2 and put it back to row 2. So that means we combine what we have 1 divided by 2 and row 2 like this. So that's negative 2m and n. So we combine, so we're gonna get the first one is 0, right? Second one is -3, m -3. And the last one is n plus 6. Okay, so if the augmented, so this is equivalent to, okay, R1 divided by 2 plus R2, put it back to R2. So what do we get is 4 minus 6, 12, and we got 0, m minus 3, n plus 6. So if you want infinite many solution, it means that m minus 3 must be equal to n plus 6. And both of them must be equal to 0. Okay, so from that, m minus 3 is 0. It means m must be 3. And n plus 6 is 0. It implies that n must be -6. So to have infinite many solution, m is 3, n is -6. All right, next one, use Gauss elimination to solve system. So I think I will write down the augmented and then you work as a homework. So from this, from the first equation, we have 1, 2, minus 3, 9. Second one, we got 0, 1, 2, 5. And the next one, we have 3, 6, minus 8, 32. That's the augmented. And then you perform, so you try to eliminate that to be 0, right? So it's like, okay, I just write the first thing that you have to do is multiply row 1 by -3 and combine with row 3, put it back to row 3. So this way you're gonna get 1, 2, -3, and 9, and you will have, okay, the second row we didn't do anything because it's already 0 in the first position here. And the third one, if you perform this, you would get the new 0 here, and the rest gonna be something else. And I left this to be your exercise. Okay, and perform thing like this. You can use backward substitution to find x, y, and z. Now, number 5. Okay, if x equal to if the system like this, we want you to find x and y. What is x and y? X is this, y is this. All right. Maybe many ways to solve. Maybe you can do the Gauss elimination again, or maybe you can just multiply this and then check what's going on. Okay, let's try to multiply. So we have 2x minus 5 must be equal to 7, right? Okay, this times this, because this equal to 7, and this times this. So we got 4 minus y equal to 3, and then solve it. Oh, here is simple. The second one, we got y equal to 4 minus 3, so that is 1. And from the first one, we got 2x equal to 12. Therefore, x would be 6. So x is 6, y is 1. Okay. So just do my matrix multiplication first and then problem simple. So we can solve for x and y. This one, find inverse using row operation. Okay, simple, right? So we can have 1, 0, minus 1, 0, 1, 1, 0, 0, 2, and augmented with the identities. And you can do some row operation. Okay, do some row operation. Finally, you're gonna get 1, 1, 1. Okay, it's gonna be the I here, and the output here would be your A inverse. So basically, in this problem, you just divide this, the last row by 2, and then you perform row operation here. That's it. Okay. So maybe I show you one step. Maybe we divide the third row by 2 and put it back to row 3. So we got 1, 0, and minus 1, 1, 0, 0, 0, 1, 1, 0, 1, 0, and 0, 0, 1, and 0, 0, 1 half. Then what we need to do is try to eliminate this to be 0. That means you keep this row, so maybe you have to perform okay, row 1 plus row 3, put it back. Sorry, I should write row 3 plus row 1, put it back to row 1. And I should do negative row 3 plus row 2, put it back to row 2. So that will lead you to the identity. Okay, because you have only these two that you have to work for. And the output will be your A inverse. Okay, just do 2 more steps. Solve this matrix using inverse. So it means that from this we can write the augmented like this. Oh, they said using inverse. It means that if A is this, okay, we know that we can compute A inverse using in this case we have 2 by 2, right? So it's like we multiply this, and it's gonna be 1 over 7 times negative 2 minus 5 times negative 3. And what's going on here? We just switch interchange the number, right? It's interchange the orders along the diagonal. So this should be negative 2. This should be 7. And then put the negative in the off diagonal. So minus 5 and 3. So that is what? 1 over negative 14 plus 15 of this. So that is so minus 1 times this. So that is 2, negative 3, 5, negative 7. So that's your A inverse. Therefore, to solve for x and y, so we have A times x and y equal to 2 and 1, right? So if you multiply by A inverse on both sides, so we have A inverse times A times xy. So on the right hand side, you would have this. So A inverse times A, this is identity. So we got x and y. Identity times any vector is going to be the vectors. Okay, that's just the vector, right? So on the right hand side, it's just A inverse times 2 and 1. Therefore, this is 2, 5, negative 3, 7, and negative 7 times 2 and 1. Then you just perform matrix operation. Okay, so we got 4 minus 3. Second one, we got 10 minus 7. So that is 1 and 3. So the x and y would be 1 and 3. All right. The shop here, they plan the shop plan to import at least $100 in total. Their budget is 19,000 baht, and the cost and the profit per $1 for each type display in the table. Okay, they want you to write linear programming formulas to find how many dollars in each type the shop should import to maximize the profit. So if we want to maximize the profit, first we should define the variable. Maybe we start with the identifying, let x1, we have how many doors? We have three types, are A, B, and C. So we got define x1 is the number of door type A. X2 is the number of doors in type B. X3 is the number of doors in type C. Okay, they want to maximize the profit. This means that we know that the profit from each type A, $1 is, you take the profit from $1 is 100 baht. The type B you got 170, type C is 80. This means that the profit P would be 100 x1 plus 170 x2 plus 80 x3, right? This is the profit because $1 you earn the profit of 100 baht. So if you have $10, it's gonna be 10 times 100. If you have X dollars, you're gonna have 100 times X1, right? That's the profit. So what we want is we want to maximize this. So we want to max P, which is this. Okay. How about the constraint? The constraint is that they want to import at least $100. So we got X1 plus X2 plus X3. This is how many dollars you're gonna import, right? So it should be greater than or equal to 100. And the budget should be limited to 19,000. So it's cost per door. So the cost of 190 times X1 plus 260 times X2 plus 180 times X3 should be less than 19,000, right? So what else? That's it. So what we need is X1, X2, X3 should be non-negative, right? That's the constraint. So if you want to write the prompt, so maybe we have a maximum of this subject to this. All right. Now, okay, the next one is just draw the feasible region. You need to find coordinate of all corners. All right. First, from this, maybe we start with 3x plus 2y equal to 6, and then we identify the feasible region that is less than or equal to 6. Okay, first, maybe we start with the 0, right? When x is 0, we're gonna get 2y equal to 6, or y is 3. So we got 0 and 3. If we have y is 0, we got 3x is 6, so x is 2. We got 2 and 0. So the first line is x is 0, y is 3 right here, and 2 is 0 right there. So we got the line like this. Okay, when it said less than or equal to 6, maybe I can pick 0 here, right? 0, 0. What happened? If x is 0, this 0, this 0, 0, 0 is 0 less than 6, right? So add the 0, 0. We put it in, we got left hand side is 0 less than 6. So this is what we want, right? Therefore, the shade area should be something here. Okay, and this one is said that x should be greater than or equal to 0. So x positive. This is x equal to 0, y equal to 0, right? Y should be positive, so it should be something like this, right? Intersect. And x greater than 0, so it should be something here. So the all intersection, it would be just this, right? So let me just use the shade area like this. Okay, this one, and we want y greater than 0, so we want this one, right? And we got x greater than 0, so it should be this one, and all region that intersect, it would be this one. So the corner would be this, this, and this. So the corner would be 0, 0, 2, 0, and 0, 3. Okay, they ask for the feasible region, that's it. Okay, in this case, they given you some feasible region like this and the corner 0, 0, 6, 0, 2, 3, and 0, 3. And with this, they want you to maximize the problem, okay? Maximize. So you just put the corners into this and check which point give you the maximum. Okay, for example, at 0, 0, we're gonna get P is 2 times 0 minus 0 is 0. At 6, 0, we got P is 2 times 6 minus 0, we got 12. 2 times 2, 3, we got P is 2 times 2 minus y is 3. So we got 4 minus 1. 4 minus 3 is 1. And 0 and 3, we got P is 2 times 0 minus 3. So we got negative 3. So the maximum would be this value, right? So the solution, the optimal, in this case, the optimal is at 0, 0, 0, 6, 0. The optimal solution is at 6, 0 with the value, with the optimal value of 12. Okay, see the wording. So we have optimal solution is the point, and the optimal value is the when you evaluate, you got 12. This is value. Okay, but this is the point. This is the value. Okay, this is optimal solution. This is optimal solution, and this is optimal value. Okay, this one, using the simplex method to solve the maximize problem. Okay, simplex is required that the right hand side must be all positive, right? And this function is fine. Now we can just transform, right? Transform this one into the slack variable. So in this case, for the first constraint, we got 2x plus 4y plus something we call S1. It must be equal to 10, right? And the second constraint, we got x minus 3y is plus something I call slack number 2 is equal to 8. And the profit is 3x minus 3x plus y plus p equal to 0. And then we put coefficient of their system in the table. So we got for x, y, s1, s2, and p. And here is your right hand side, right? It's going to be 10, 8, and 0. So the first one is s1, right? Equation related to s1, we got 2, 4, 1, 0, 0. For s2, we got 1 minus 3, 0, 1, 0. For p, we got, here is the p, right? We got negative 3, 1, 0, 0, 1. So to do that, we see that this one is most negative. So this is going to be your pivot column. Now we check the minimum test. So the minimum test, we got 10 divided by 2, we got 5. Here we got 8 divided by 1, we got 8. So the minimum test, it tells you that this is your row pivot. So the next one, what we have to get is x would be replaced s1. So we got x here, and s2 is still the same. So now we want this to be 1, and other than that will be 0, right? To perform the row operation on that. All right. First, divide the first row by 2. Okay. So row 1 divided by 2, put it back to row 1. We're gonna get 1, 2, 1.5, 0, 0, 5. For row 2, we're gonna using this, right? So the new, this one, we put the row, negative row 1, row 1 new, okay, plus row 2, put it back to row 2. So let me do outside, negative 1, row 1 new. This gonna be -1, -2, -1/2, 0, 0, -5. And the row 2, the old row 2 would be 1, -3, 0, 1, 0, 8. Now we combine. Okay, combine the two, we got 0, we got -5, we got -1/2, got 1, 0, 3. So the new row 2 would be 0, -5, -1/2, 1, 0, 3. How about the row 3? Row 3 is, so we use this row multiplied by 3 and add with the row 3, right? So we got 3 times row 3, oh no, row 1. 3 times new row 1. Combine with the row 3, put it back to row 3. So it's like we have a multiply this one by 3. So we got 3, 6, multiplied by 3, we got 3.5. Got 0, we got 0, we got 15. So combine these two. We got this is p, we got 0, 7, 3.5, 0, 1, and 15. So I erase all that. Okay, that's it. We have no negative value here. Therefore, from the simplex method, you can read that the optimal solution is, okay, the optimal solution. Okay, the optimal value is this. This is optimal value. Okay, optimal value. Optimal value is 15. Optimal solution is would be the value for x and y. So this is x and y. Okay, x is what? We can have the x is 5. and we have no y here. This means that y is 0. Okay, that's it. All right. Next one from the original problems. We want to write the dual problems. So the dual start from the minimum. The duality, we don't care about the positive or negative here. Right. Hey, let's review what's going on for the duality. Let me review myself as well. The dualities. Let's see, where is my dualities? That's big M. The duality. Okay, is required greater than or equal to, okay, and then we're gonna create a metric A and then compute A transpose and then rewrite the modified problem. So let's go back. Okay, all we need is this, right? But here we need to modify this require modification, right? Because we need all of the constraints should be greater than or equal. Therefore, we multiply this one by -1. So we got minus 8x1 plus, not plus, negative minus 9x2 plus 3x3 greater than or equal to 18. Now, we can perform A. So A would be, okay, the first constraint is 8, -8, -9, 3, 18 on the right hand side. The second one, we got 5, -2, -4, 26, and the C. Okay, the C is 7, -6, 1, and we use the star term, right? This is your A. Now compute the A transpose. So we got -8, 5, 7, and -9, -2, -6, 3, -4, 1, and 18, 26, and stars. So we start from x1, x2, x3. Now we're gonna have here it's like y1 and y2, the new variable. And here, right? So what we need is that we start from minimize, so we're gonna maximize. Maximize, maybe we call the C, and using this as the C. So we got maximize of 18y1 plus 26y2. Okay, subject to the constraint that we have is the first one is -8, -8 y1 plus 5 y2 less than or equal to 7, and we want let's see, if we want to solve that, is that okay? The next one is -9 y1 minus 2 y2 less than or equal to -6, and the next one is 3y1 minus 4y2 less than or equal to 1. Okay, and the y1 y2 is non-negative, but in this problem you cannot apply the simplex. directly because of we got a -6 here, but the problem doesn't ask you to do anything about solving, so that's fine. So notice that this case simplex doesn't work, right? The simplex, all you need is the right hand side should be positive. In this case, doesn't work. But we have the another type of optimal, but that's okay. We don't care about this problem. The next one, we want to minimize problems with the variable x1, x2. Okay, minimize C. Whereas the dual problems is variable y1, y2, y3. So the table related to the dual problems is shown in the table here with the variable y1, 2, 3. And they say that this is the final state of after we perform the dual problems and we perform the simplex method. We got this table with the slack variable s1, s2, or maybe we can call the original problem x1, x2. That's fine. But in class we use s1, s2. Okay. Now, from the table here, they ask for you have to be able to interpret the table. Here, it's going to be your optimal value. From this one can be the same optimal as in minimum problem and the maximum problem. So the optimal value is 13. The optimal solution of the duality. So the dual problems is related to the y, right? Now, you can see that y2, y3 is showing up here. That means y2, y3 is this. But y1 no showing up. It means that y1 is 0. So it means y1, y2, y3 is 0 because no c, no y1, right? No y1. So it should be 0. No y1, or it means that y1 is 0. Now, y2 read from the table is 4 and 5. So that is y2, y3. Okay. How about the original problem? The original problem you read from this one. This is original. The original problem is x1, x2. x1 would be 2, x2 is 1. Read from this. All right, that's it. The next one is related to the modified problem of the big M. Okay, let's review the big M a little bit. The big M all constraint must be non-negative on the right hand side, but inequality on the constraint, it can be anything, but we can add the slack variable or artificial variable. All right, all we need is positive, so this one we need to modify, right? So we modify that to be multiplied by -1. We got minus x1, 8x1 minus 9, x2 plus 3x3 greater than or equal to 18. Now, from this, we can set up the preliminary table. Okay, oh, they ask for the modified problem only. So modification problem would be max of C equal to something, right? 7x1 minus 6x2 plus x3, but maybe we have to add the m, but we haven't seen that yet now. Let's start from the first constraint. Minus, okay, subject to, I use the chart ST, minus 8x1 minus 9x2 plus 3x3. On the left hand side is already over 18. This means that we have to subtract by some surplus, right? I call that surplus S1. When you have surplus S1, you have to add the artificial and make that up to be 18. For the constraint number 2, got negative x2 plus x3, 8x3, and it's already equal to 10. So we just add the artificial. Then the third condition, we got 5 negative 5x1 minus 2x2 minus 4x3 is over 26. So we subtract off by, we have S1 already, so S2. And when we have subtract by the surplus, you have to add artificial, so it's called A3. And that is equal to 26. Okay, so now the C should be modified, right? Because you have artificial A1, A2, and A3. So in the original problems, you have to add the big M. Okay, let's see. We modify the problems. When you have the A like this, you're gonna subtract it off in the original problem. So the P, the C here is 7x1 minus 6x2 plus x3. And then you subtract off MA1 minus MA2 minus MA3. So that's it. This is the modified problems. They didn't ask for the solving. So that's it. Okay, big M showing up here. Okay, given the simplex table associated with initial simplex maximize problem like this, complete the next pivot operation. Okay, they already removed the M in the column of A artificial already. So the next one, we just find the most negative in the simplex, right? M is a big value. Here is negative M, so it's very huge negative. Therefore, this is your pivot column. Now, you do the mean test. So only divide by non-zero, right? So we got 6 divided by 1. So we got 6. So that is your next step. So we're gonna have X, Y, Z, S1, S2, A1, maybe P, but here they didn't have the P. That's why, because P doesn't change, right? The P column doesn't change. Now the first one is S1 here. The C should be replaced in A1. So we're gonna get the C variable right here and the P. So what we should do is that, because this is already 1 and this is 0, now we only need to remove that, make that to be 0. So the first row is keep the same, right? 1 0 0, 1 0 0, and 2 doesn't change anything. The second one, because already 1, so we didn't change anything. But we change the last one. The last one is that we need to do is multiply the second row by M plus 1 times row 2. Okay. And then combine with the row 3. Put it back to row 3. Now, if I multiply M plus 1 row 2, we're gonna get 0 minus 3 times M plus 1. And M plus 1 and 0 minus m plus 1, m plus 1, and 6m plus 1. And make sure you write in parentheses so that you save with the sign. Okay, in row 3 is minus 2, 3m minus 7, minus m minus 1, 0m, 0, negative 6m. So we combine these two, we're gonna get negative 2. So we got negative 3m, this gone, and negative 3, negative 3, negative 7, so it's negative 10, right? And here, negative m and plus m is gone. So 1 minus 1 is gone, so 0. Next one is 0. The next one is negative m and plus m. So we got negative 1. And we got m plus 1. The last one, 6m minus 6m. So we only have 6. So that is your next step of simplex. All right. Again, this one is a doll company has 3 factory A, B, and C. They send the dolls to cargoes number 1 and 2. Cargo 1 wants at least $700 per day. Cargo 2 wants 500 per day at least. Number of doll from each factory. They have some transportation costs, right? Okay, they can produce, each factory can produce this. And transportation cost to cargo 1 and cargo 2 is this. So maybe China yuan per $1 like this. So just draw the picture. So there are 3 factories. So factory A, if factory A send the dolls to cargo C1 and cargo C2, right? Same as the B go to C1 and C2, and C go to C1 and C2 again. All right, let's define the variable. Maybe we define x1 as the number of dolls sent to cargo 1. X2 is the number of dolls sent to from A is 2, right? This is from A, from fact A to cargo C1. This from factory A to C2. But X3 is the number of doll from fact B to cargo C1. X4 is the number of doll from fact B to C2. And X5, X6 is the from fact C to C1. And X6 is number of dolls from fact C to cargo C2. So they just want you to define the variable. And also write the transportation cost. Okay, transportation cost. Write the transportation cost. Which one? This, right? Cargo C1 and C2. To minimize the transportation cost. Okay, 3 yuans per $1. Therefore, from A, okay, if the number produced Cargo one want at least $700 per day. Okay. Does from factory A is 900. It means that x1 plus x2 is equal to 900, right? Okay. But here we have x1. Let's see, we're gonna get x1 plus x2 is 900. And here is x3 plus x4 is 600. And x5 plus x6 is 800. But transportation cost, okay, if x1 to cargo one is cost $3, so we have $3 and how many x1 to cargo C1, right? And x2 that has the cost of $6 for x2. This is the cost for from factory A. And cost from the transportation from factory B is $1 for X3 plus $4 for X4. And transportation cost for factory C is going to be 2 times X5 plus 5 times X6. This is from transportation cost from factory A, B, and C, right? Let me read the question again. They have 3 factory from different places. Right, linear programming formulas to minimize the cost. Okay, the cost should be combined, right? This plus this plus this. This is your cost. This is the cost. So we want to minimize the cost, minimize the C, which is 3x1 plus 6x2 plus x3 plus 4x4 plus 2x5 plus 5x6. Okay, that's the cost. And condition. So we have here is the condition x1 plus x2. Let me add the page. Okay. Let me copy all that. Oh, we have small space here. The cost is, so mean cost is 3x1 plus 6x2 plus x3 plus 4x4 plus 2x5 plus 5x6. That's the minimum cost subject to x1 plus x2 is 900, x3 plus x4 is 600, and x5 plus x6 is 800. That the number of dolls each factory can produce. And how about cargo one want at least 700 per day? Okay, so this is x1 plus x3 plus from factory C is x5. That's number of dolls sent to cargo number one. Cargo number one want at least 700, so it's greater than or equal to 700, right? And cargo number two at least 500 per day. So we got x2 plus x4 plus x6 greater than or equal to 500. So x1, x2, x3, x4, x5, and x6 is greater than or equal to 0. So that's it. This is your minimized problem. All right, the next one is simple. Just evaluate the they have the piecewise function. Here, let me separate the domain. For here is x is 0, right? It's separate. If x less than 0, we got function 3x squared minus 2. If it's greater than 0, we got 3 square root x minus 2. And they define that gx equal to 2. Okay, gx is a constant for any x. Now, g at 1. So because g of x is 2, right? G of x is 2. So when you put any x, you're going to get 2. Therefore, g of negative 1 is 2. Now, what is f at 0? F at 0, because 0 is going to be on this side, right? So it's going to be 3 times square root of 0 minus 2. That's f of 0 plus g of 1. Again, g of anything going to be 2. So we got square root of 0 is 0. So we got minus 2 plus 2, it is 0. Next one is f at negative 1. So f negative 1 is right here, right? So we're going to use 3 negative 1 square minus 2. That is f at negative 1 time g of 0. G of anything is still 2. So we got 3 times negative 1 square, it's 1. So this times 2, so we got 1 times 2, we got 2. Now sketch this graph. This way, if I write again with the y equal to 6 minus this divided by 2. So if I multiply both sides, maybe multiply both sides by 2, we got 2y equal to 6 minus this. We can write 2y minus 6 equal to negative of this. So maybe we can have this. All right. So we know how to draw the graph of absolute value, right? For example, we have y equal to absolute x. This is going to be the V shape, right? But y equal to negative x, this is going to be like this thing. And because of this and this, it's going to be shifting the graph. Okay, just roughly sketch the graph first. So this shifting this graph, right? Shifting this graph to the right, shift to the right, 1 unit. And this is shifting up 3 unit. So it's going to be like here, shift to the right, 1 unit, here, shifting up 3 units. So the top should be something like this. And the 2 here is just modification of the graph. Okay, so basically you're gonna shift the graph to here's 1, and the vertex gonna be 3 right here. So the top vertex should be right up here. And you can easily point out maybe this one or which one by maybe you pick the x. When x is 0, what is the y value? Okay, that's how that's how we draw or sketch the graph. Okay, for example, if we have 2 of y minus 3 equal to negative of x minus 1, right? If x is 0, I mean x is 1, it's better choose x equal to 1. Because x is 1 is going to be 0, right? So when x is 1, you're going to get 2 times y minus 3 equal to 0. That means y going to be 3. Oh, it's right here. It's already there. It's not good. Sorry. Okay, again, try and when x is 0. X is 0 is 2y minus 6 equal to negative of negative 1. So we got negative 1. So we got 2y minus 6 equal to negative 1. So for y, so we got 5. So y is 5.5. Okay, when x is 2, y is 5.5, which is 2.5, right? It's going to be right here. And when x is 2, if x is 2, we got 2y minus 6 equal to minus of absolute value of 2 minus 1. So it's going to be negative 1 again. So 2y minus 6 equal to minus 1. So 2y equal to 5. So again, y is 5.5. Therefore, we're going to have, when x is 2, we got this. Therefore, the graph should be like this. Maybe you can find when y is 0, what is x? That might be easier. Okay, maybe try y is 0 and x is what? Then you can find the intersection of x somewhere. For example, if y is 0 here, right? So we got negative 6 equal to minus x minus 1. Oh, it's difficult. I think it's difficult for you because it's absolute value. No, I don't recommend you to pick y equal to 0 because of the absolute value. You need to use the definition of absolute value. It's going to be difficult. Okay, this is difficult. Okay. All right. Next, maybe it's easier if you write this way. So that is y minus 171 equal to x minus 206 squared. And because of parabola, the original graph is y equal to x squared is like this, right? Then this telling you that shift to the right, and this telling you shift up. So the vertex from 0, 0, it shift up to be x is at 206 and y is at 171. And the axis of symmetry gonna be from y-axis, right? It's gonna be moved to somewhere here. So it's gonna be x equal to 206. X equal to, okay, don't forget the x. So that x equal to 206. And the range is mean that this is starting, right? It's gonna be more than y value. So y is greater than or equal to 171. This is how we use the shifting the graph. This one, the domain of this are the rational function, right? So the denominator cannot be 0. So domain is x cannot be okay, 3x minus 2 cannot be 0. It means that x cannot be 2/3. And x plus 5 cannot be 0. It means that x cannot be negative 5. So x is not equal to 2/3 and x is cannot be negative 5. The horizontal, asymptote, and vertical, this is no need, okay, for this. All right, show in detail how to compute this one. Oh, because of the sine and cosine, we don't cover in this class, so no need because of trig function. Okay. How about this? Okay, this one you can notice that it's gonna be log of 3. Everything is log of 3. So we're gonna use the log of a times b equal to log of a plus log of b, something like this. And if you have the negative, it's gonna be division. So so maybe we have a log of 3 of 2x plus 1. Okay, let me rewrite. This term is gonna be negative 2 log of 3. This, right? This is equal to negative of log 3 2 square. Right? So the original, the left hand side combined together is going to be log of 3 times 2x plus 1. The second one, because of negative, right? So it's going to be divided by 2 square. And the last one is x because of negative equal to 0. And what is log equal to 0? Log of something equal to 0. Log of 1, right? Log of 1 equal to 0. Is that right? Let's go back to the original, the beginning of the class. The property of log of 1 equal to 0. So that, which one? This one. Okay. So what we need is, so because of log of 1 equal to 0, it means 2x plus 1 divided by 4x must be 1. Now you can solve for x. Maybe we multiply both sides by 4x. So we got 2x plus 1 equal to 4x. Notice that here x cannot be 0, right? Yes, x cannot be 0 because it cannot divide by 0. Now we subtract both sides by 2x plus 1. So we got 0 equal to 2x minus 1. Therefore, we got x is 1/2. So that's going to be your solution. Here's sine, cosine. Okay, we don't care about that at all. That's it. All right. That's the mock exam that I cover up. All right. We have 10 p.m. already. So I just better stop the class now. All right. If you have any question, just send me the message. All right. Have a good night.